No, the 80s is the last day, the 90s.
Okay, let's do as many problems as we can in whatever time we have. We got what, 20 minutes left?
So wow.
And these are the hard problems now. I hope you guys try them because
Easy.
that's the, if you haven't figured this out, that's the secret to math.
Practice.
Yeah. Okay, where are we on? Maybe we should go backwards because some of them are not that hard, yeah?
Yeah.
Like 24, could you do the coffee problem? Okay, let's just do it. Okay, but we gotta do, I wanna get on video 36 and then 30. How many people actually got number 30? You really didn't? No, that's what I thought.
Oh. Next time we're gonna get it for you.
I hope so. Take that as a challenge. Okay, look. This is the same cone problem we did for homework, except there's coffee. So in the original one there was water, but changed it to coffee and we can't do it now.
Coffee's different.
And then, isn't that the same from today's quiz?
Yes.
So coffee is dripping out of this filter at the rate of, what does it say? 10 cubic inches per minute. And it is dripping into a cylindrical pot. Here's the pot, like this, and here's the coffee in the pot. So, what is dVdt for the coffee in the filter? Negative 10, because it's getting smaller. But what is dVdt for the coffee in the
Positive.
positive 10? You guys understand? The coffee is coming out of this one, but it's going into that one. So when you do this problem, dVdt is going to be negative 10, but for this one it's going to be positive 10. Did I start the video? I better have.
I'll check.
Okay, now, same thing. Once you see this problem, and they put this problem every so many years on the AP exam, you gotta know it's similar triangle. So, same like today's one, R and H, and then what are the dimensions of the coffee pot? 3 and 6. That sounds, is that the same as today? Was it?
Oh,
I don't know.
It wasn't.
So the volume of the coffee in the filter here is, that's a cone, 1/3 pi r squared h. But we gotta do similar triangles. So looking at the triangles, what? R over h equals 3 over 6, which can be reduced to 1/2. So R is equal to 1/2 h. Take that and plug it in there. That's exactly what we did on today's quiz. That's exactly what I did. 1/2 h squared times h, and all of that simplifies to pi over 12 h cubed. Did I do that correctly?
Yes.
Mr. Park, we're just copying what you're writing on the board.
Yeah.
Don't ask me questions. Take the derivative, dVdt is equal to pi over 12, throw it on the side like an unwanted pet, and then you get 3h squared h dot. See, I just automatically do that because that's how every problem is. What is this problem? How fast, oh, we're doing part B first then. That's okay. It's probably better if we do part B first. How fast is the level in the cone falling? So they want to know dH/dt, h dot. So if I'm going to compute h dot, you need to know v dot and h. Do they tell you these things?
Yes.
What is v dot for the filter?
-10.
Negative 10. And what is h at the moment when the height is 5 inches deep? So 5. So therefore, h dot equals, let's put this together, -10 times 12 over pi times 3 times 5 squared, which is 25. Can I do any canceling?
Yeah.
You bet your bippy I can. 3 goes into 12 4 times, 5 goes into that 2, and that into 5. What did I just say? That's a 2. 5 goes into 2 times. So you got -8 over 5 pi, and the units are going to be inches per minute. Okay, we did part B first. How fast is the... Okay, now, for the coffee pot. Now notice that the radius of the pot doesn't change like over here. When the coffee is draining out, the radius changes, but over here, doesn't the radius stay the same the whole time?
Yes.
Since it's a cylinder? And that radius is 3 inches.
So you don't need to-
But when coffee is being poured into here, the height of the coffee changes, so you label with the variable. So just looking at this picture right here, what is the volume of the coffee in the pot? It's a cylinder now. What's the formula for cylinder?
Pi r squared h.
Pi times the radius squared times the height, which simplifies to 9 pi y. Come on, this is an insult to your loins right here. So V dot is equal to, throw the 9 pi on the side, like an unwanted pet, and then the derivative of y is y dot. So to find y dot, you just have to substitute a number for V dot. But what is V dot for the coffee pot? Positive 10, because the coffee is going in. The volume is getting bigger. So therefore, y dot for the coffee pot is 10 over 9 pi, and I guess it's going to be inches per minute. Okay, look, how many times have we done this problem right here? This is the 3rd time. Once on the homework, once on the quiz, and another time on the homework. Probability is quite high that you probably can do it on the test again too. You know why I always give it on the test? Because AP exam, they put this on every 2 or 3 years, that's why. So you gotta know this, you gotta know you gotta use similar triangles. Okay, how much time do we have? We're running out of time. Shall we skip to number 30? You know, man, we're not gonna, I don't know if we're gonna even get to finish all of these. Number 30 is probably the hardest one, you know. Yeah, I know, but then maybe,
No, do it.
okay, let's do it now. Okay, telling me what to do. Okay. Here we go, so we have a light. Whoa, I'll tell you what, before we do number 30, you gotta understand number 29.
No, 30.
No, but you gotta understand 29, how it works first.
Kids do 29.
Did you guys even try it?
I looked at it.
Oh, gosh. Looked at it, okay, that's all. Okay, a man is 6 feet tall and it's walking at the rate of 5 feet per second toward a street light. So here's a street light. Now, does the height of the street light change?
No.
No, it is. It
Constant.
is 16 feet. What about the height of the man?
No.
No, he is 6 feet. And he is walking toward the street light. So this distance is changing. What do you want to call that?
X.
Okay, and then the top of the light shines on the man, and it makes a shadow. So here's his shadow right here. Now, as he walks toward the street lamp, does the length of his shadow change or stay the same? It changes, so you label that with a variable. That's what your picture should look like. Yes, you're copying it down now. Okay, now what equation can I write?
Pythagorean.
No. Similar triangles. Look, you got the small triangle and then you got the big triangle. So y over 6, long leg over short leg in the small triangle, gotta equal long leg over short leg in the big triangle. So what is that?
X over 16.
No. X plus y over 16. That is your equation. Now, do you want to take the derivative of that now, or do you want to simplify it? Hey, you know, I went to visit Mrs. Yanashiro's room yesterday, doing the same problems we're doing. Because on the board I saw, you know, the sand falling from the conveyor belt? They did the problem. How come they can do it and we can't?
Wait,
No, it's on the board because they can't do it.
they're on 4.4.
I saw that on the board. I went in her room yesterday for lunch.
Yeah, it's on the board because they can't do it. And we can.
Well, I'm doing all the problems for you, so what does that imply? What does that imply? Okay, cross multiply. 16y is equal to 6x plus 6y. Consolidate, so you get 10y equals 6x. Divide by 2, 5y equals 3x. Okay, that's your equation. Isn't it easier when you simplify?
Yeah.
Okay, now take the derivative of both sides. 5y dot equals 3x dot. That's easy enough. Okay, now what are we asked to find? Okay, where's the problem? Let's read, since some of you don't even have your book. A man is walking at a rate of 5 feet per second toward the street light. So what do I plug in for x dot?
5.
No, -5. He is walking toward the street line, so x is getting smaller, -5.
That's your problem.
And then it says, at what rate is the length of his shadow changing when he is 10 feet from the base of the light? So we need to find y dot. So where do I plug in the 10?
Just solve with that.
Where do I plug in the 10?
Pythagoras theorem.
No, you had it the first time. You don't need it. You can solve for y dot already. Just divide by 5. Y dot is -3. And I'm going to let you put on the units because I do everything for you. You put on the units.
So what are the units?
I'm not going to tell you any more units for the rest of this chapter. I'm done. So what's the meaning of the 10? You're supposed to plug in 10 for x, but then there's no x there, so you don't need it. They gave you extra information to try and throw you off the scent.
They're gonna do that on the test.
Doesn't mean it doesn't matter how far it is.
Yeah, so it doesn't matter how far he is from the street light, it's always going to be changing it. -3, whatever, per whatever.
Dude.
This better be good.
No, yeah, so are
Just like the question you asked on the quiz. How about read the directions and it'll
No, because then I didn't know, because then it was a different on the homework, and then I did it on the other. Not important. On the AP exam, are they gonna do that?
No. Okay, next, number 30. Now we do number 30. Okay, now this is a variation of this problem. You're going to use similar triangles, but now the problem is super hard now. I put this on a test one time. Oh, all hell broke loose. Okay, here's a street lamp, 50 feet tall. Now here's a ball. Okay, this distance doesn't change. That's 30. So 30 feet away, there's a ball here, and you drop it. What happens when you drop the ball?
It falls.
It's going to fall like this.
You're out of-
So it says they're talking about half a second after you drop the ball is going to be what, around there?
Yeah.
I don't know, I just make up something. So the light's going to shine on the ball, and the shadow of the ball is going to be right over there. What?
No, the ball's a soft.
Okay, so when I drop the ball, does this distance change or stay the same?
Change.
No, it changes. What do you want to call it? Y? Okay,
Oh,
since it's vertical. And then here's the shadow of the ball over there. The distance from here to here, is that changing or staying the same?
Changing.
It's changing. Why do I call it
Wait,
X?
why is it changing again?
Because if the ball is moving, the shadow will be moving, right?
Oh. Oh, okay.
This is the shadow of the ball right there.
Oh, okay.
Okay, now look at this picture. What equation can I write?
Similar triangles.
Similar triangles. It's the same problem except different. Except because, okay, so you got the small triangle and you got the big one. So x over y equals
30 plus x.
over.
50.
Okay, there you go. That's your equation. Now, do you want to take the derivative of this like this, or do you want to simplify it?
Simplify.
Okay, cross multiply. 50x is equal to 30y plus xy. That's your equation. This is not the hard part now. The hard part is the plugging in the number. This is the easy part. Because probably on the test, I'll probably give you this picture. And I'll even put the x and y in just because you guys are who you are. Okay? So now, take the derivative with respect to time. I'll do the first two. 50x dot equal 30y dot plus, and then come out of it. Derivative, quick.
X. Y dot.
Gotta be different. Plus,
Plus Y. X dot.
who even does that? The rest of the class, we do it the same way all the time except you.
Wait.
But it doesn't matter, that's correct.
It doesn't work. No, like you
Yeah, no, that's correct.
you think of it like you start with X and then you get the derivative of Y.
But then the way we learned it, the way the rest of the class learned it, derivative of the first, leave the second one alone. Plus leave the first one alone, derivative of the second. Maybe we gotta make up a rhyme for that.
I don't like that.
Oh gosh. Okay, what are we trying to find? How fast is the shadow of the ball moving?
X prime.
No, x dot.
X dot.
Now, in order to find x dot, okay, in order to compute x dot, we gotta know x, we gotta know y, and we gotta know y dot. Now, in this problem, the reason, I mean, this is basic, right? What makes this problem difficult is computing these things. Because normally they tell you, or at least some of them, but this one, you read the problem, you get nothing. You got nothing. Nada. You gotta figure out everything. Okay, so here we go. Oh, here's a hint. Assume the ball falls a distance s equals 16 t squared feet.
Ooh,
Right? That's a physics formula, right?
yeah,
You guys know what 16 is, right?
yeah,
What?
constant.
Yeah. What is the meaning of it? Come on, everybody here took physics. What is that 16?
4 squared.
That's 1/2 g.
What?
Gravity.
Gravitational
this-
acceleration,
32.
32.2 feet per second squared. That's half of that.
Oh.
Yeah, but Mr. Burke, we use 9.81 meters per second squared, but we're doing feet. Okay, so if I drop a ball from 50 feet, okay, half a second later, how far did it fall? You use that formula. Plug in half.
4 feet.
Okay, it fell 4 feet, which means at the moment in question, what is y? 46, there you go. See, you gotta do all that work just to come up with that. Now, if y is 46, how do I figure out x?
Original equation.
Yeah, you can either use this one or the simplified one. I think I'd rather use the simplified one. So if you plug in 46 for y here and here, you can figure out what x is, right? Okay, let's do that quickly. 50x is equal to 30 times 46 plus x times 46. So therefore, 4x is equal to 30 times 46, divide by 4, which is, just divide each one by 2, could be 15 times 23, which is 345.
Yeah.
How do you know?
30
Because whatever I say is correct.
30 times
You got,
22.
that's so weak. No, just do this. 23 is 20 plus 3. And distribute the 15, so you get 300 plus 45.
Can't you just do 30 times 11 plus 50?
Or you can just go on the side and go 23 times 15, 5 carry the 1, 3, 2, 5, 4, 3. How about that?
Okay.
We're just wasting time doing it. Why are we, oh gosh. We're in trouble. Okay, now what about y dot? How fast is this distance changing? Okay, let's see if anybody can come up with this. Now, I know most of you didn't even read this problem, but let's see if we can figure it out.
Wait,
How smart is period 7? Oh! How do you figure out y dot? I mean, there's really no information here. Okay, I'll give you a hint. It has something to do with this equation.
Can't you just plug in 50
Why
for...
Oh.
Just plug in 50 for x.
Oh.
What?
What is y dot? Because if I don't,
Why not equals derivative of the 16?
oh!
Oh.
Hayakawa! Did I get the name right? Hayakawa! He said take the derivative of this because if you have the position equation, the derivative tells you the velocity. So therefore velocity is what? 32T. Yeah, that looks like a formula from physics. Duh. All of those formulas from physics were derived using calculus.
Really?
That's why Sir Isaac Newton invented calculus, so he can further his studies in physics. Okay, so if I drop a ball, half a second later, what will its velocity be? Plug in a half here.
16.
16 feet per second. So tell me, what is y dot?
16.
No, it is negative 16. Because when you drop the ball is going that way, y is getting smaller. Okay, take these numbers, plug it in here, and then you guys compute x dot. Use a calculator if you must.
Hey, you could have just figured out 16.
Okay, we only got like 1.5 minutes, okay? I just want to start you on 36 and then you guys are going to finish it at home tonight. Anyway, if you look on the website, there's 2 worksheets and I give you complete solutions now. Oh, can I just print it out and hand that in? Oh, no, you gotta copy it on your own. Yes. Is that what you're gonna really do?
No, of course not.
Of course, I know some of you are gonna do it.
Practice math.
Okay, here we go, 36. Just a hint, okay, here we go. Two boats are moving away, so here's point O. Ship A moves that way. Look out there. Ship B goes that way, but this angle stays 120 degrees, it doesn't change. So it's moving away. So the distance between the two boats is changing, right? So this distance is changing, this distance is changing, and that distance is changing. Look at that picture. What equation can you write? You got 30 seconds.
Law of cosine.
Law of cosines, because this is not a right triangle. So here, let me give you the law of cosine for those of you who forgot it. Z squared is equal to x squared plus y squared minus 2xy cosine of 120 degrees. Yep. Okay, I'll start you on that problem. Finish it. Take the derivative and plug in the numbers.
Whoa.
I'll give you a hint. I gave that problem on last year's test, so.
Was it just paid?
No, it's so easy.
There was no
Except I put a twist in it. I said, instead of this angle staying the same, it changes. Yeah. I don't know what that means. Okay, tomorrow we got a lot of work to do.
Can't you just do different squares?
Oh.